Good evening, Professor. I have a multi-threads assignment here. I had uh I had ran the program and I had set it up with a handful of expenses. This way I don't make you wait while I type that out. I had set the program with all these breakpoints so we can make the observations of the threads uh, iterating as the program goes through the code. And so I have only commented on the piece of the code that is new to this app, uh, which are going to include these directives, these preprocessor directives, uh, the thread the thread libraries, uh, an atomic and a chrono for to help thread for our libraries, atomic to create this flag, the save uh, to create a save flag. This way, there's no complications between the threads. Uh, I had, I had, uh, I had included the atomic uh, for a few reasons, uh, because of the shared variable save completed. Uh, this way we could attach this function, this flag, and make it assign it mutable so it can be utilized throughout the code, whether or not the function is is what is it constant. When they're constant functions, they could uh, we could still have this function flow through our code to make sure it stays sound. Uh, it uh, it creates thread safe updates. Um, once the code is saved, once it'll save to true. So that's why we're using that one instead of mutex because it minimizes overhead and it avoids potential deadlocks. Using mutex, if I have my in my notes here, it updates the save completed and in the main thread, it tries to acquire the mutex at the same time to check save status. The threads could become stuck. So, so we're avoiding mutex. Uh, so the so the program doesn't doesn't jam. And so following that flag, we have this. We are declaring our vectors for this thread vector and this partial sums uh, double vector, so we can store our the threads that we accumulate partial sums. We store them in this double vector and these the threads in the thread vector. We're using a lambda function, uh, and we're setting it to auto to deduce um, this lambda expression. This way, it's less overhead, better user experience, and yeah, for all those great reasons. We have in our function block, right? We have this expenses that get this is a shorthand for uh, for our sum adding expenses equaling our total sum. But let me let me run it, and we can see it. Uh, we can see it down here in our window. Let me bring it over and finish it. So I have it done here, and and here we are with our threads. Uh, we have four threads assigned, and we're using this to call our tracker uh, to make it easier. Uh, but here we are, and once we hit this and place back operator, it'll put us back to the top of our lambda uh, function. So as we can see, we have one index so far, and let me F10 this here. As you can see, we are cycling through, and now we have two indexes, two threads out of four. So it's gonna iterate again as I F10 through the code here. And there we have three, and and now we're joining all our threads. We're waiting for main's waiting for all of our working threads to join in this function. And here we come up to our expenses. It adds it to our expenses and our partial sum. As you can see, here's our sum so far using a double type variable. And this is our for loop. Uh, our for loop for our lambda function iterating over and over again as it accumulates our expenses. Take us to our next function. You see it operating right here. Here are four, four threads, four threads running. A total sum. I did the longhand on this function here just to change it up, and I put a description right here for the shorthand. As you can see, how I wrote it up here. Uh, to yeah, it's all in my code, in my comments. I don't want to take up too much of your time, but just commenting how this lambda uses the capture list to reference to assist in overhead. So I don't need to rewrite a redundant amount of code As you can see, it references down below here with in this save code right here in the save thread code. And as I mentioned, this right here referring to our class instance to make it to make it easier. I'm starting to implement that to make it a lot more user friendly, better user experience, and learning how to navigate to demonstrate is also a skill I'm still building here. But I'm trying to get us through this through our code. Here's our final flag for the code to give us our true Boolean flag once we reach a successful save through our asynchronous uh, programming, our asynchronous threads running here in parallel. Um, I guess I could compare these asynchronous files, threads running as electricity running on a parallel circuit, and concurrent operations running as the components on a parallel circuit. But yeah, we're not going to fall off too far off track here. Here's our our while loop to to load our save our threads to be saved, and with this timer, so it doesn't slow down the CPU to create too much drag. That was the purpose of the chrono um, library. Uh, Other than that, um, yeah, our final output to our upstream function um, to print to save it to our external file. File name right here, expenses text, yeah, saved, size 12, um, unassigned 64-bit. It's running on a 64-bit, and here it is. Success, true. And that concludes my demonstration. I hope that was sufficient. A lot of information I'm trying to go through. Thank you. I will send you the final by tomorrow evening. Thank you.